All right, so today we're going to start in the first couple of sections in Module 3 where we're talking about probability distribution. And in the last module, we talked about a probability distribution. It's basically a distribution that contains one column is the random variable, and the other column is the probabilities, right? And then all probabilities in the probability distribution must add up to give you a 1. Today we're going to talk about two types of probability distributions. The first is a binomial distribution, and the second is that standard normal distribution, the bell-shaped curve, the empirical rule, which applies to that. So we're going to start out first with the binomial distribution, right? And here's just the explanation of the binomial distribution. It deals with proportions. So remember that a proportion can be written as a decimal, and the decimal can be written as a percent. Okay, so in this binomial distribution, we're dealing with proportions. In the word binomial, that prefix is bi. If you think about a bicycle, it has two wheels. For our binomial distribution, we only have two outcomes, right? The outcomes could be pass or fail, yes or no, good or bad, male or female. Okay, there's only two outcomes. And here is some notations for the binomial distribution. P of S, what you see, that's equal to P. And P is the probability of success. In the problems that we're going to be working with, you will be given the probability of success. All right, so P of S equals to P. That's the probability of success, which is the same as the P that's further down on the list of notations. The probability of success in one of n trials. Okay, so the P is a probability of success. And then we have P of F, which is read as the probability of failure. That's going to be 1 minus P, right? So keep in mind that if 1 is 100%, right, and there's only two outcomes, P would be the probability for success. The probability of failure is going to be that 100% minus the probability of success. Okay. The probability of failure is also known as Q. And normally you got to calculate Q, right? They'll give you P. They will also give you N, right, in the problems. And taking a look at the notations, N is the number of fixed trials. So by fixed trials, they mean N could be the number of people sampled. N could be the number of successes. Okay, so N would also be given to you. Okay, and we're going to see examples where these things are showing up. X is going to be the number of successes. Okay, here again, so P is the probability of success in N trials, Q is the probability of failure, and P of X is the probability of getting X successes. Okay, so these are the notations that we're going to be used going forward as far as the binomial distribution is concerned. All right, so now we're going to just take a look at some definitions. And a binomial probability must meet the following requirements. The procedure has a fixed number of trials. Second, the trials must be independent. Third, each trial must have one of two outcomes, either, and it says it's commonly success or failure. All right, so each trial must have two outcomes. And since the trials are independent, the probability of success remains the same in all of the trials. All right, so 4 conditions. It has a fixed number of trials. The trials are independent. There's only 2 outcomes. And the probability of success remains the same for all of the trials. All right, now we're going to take a look at some formulas for the binomial distribution. Now, for whatever reasons, the formula didn't print out on this page, so we're going to write those in. So I'm going to just bring up OneNote, and I'm going to do that over here. So here are the formulas for the binomial distribution. Right, so we have the probability of x, right, and P of x would be the probability of x successes. That's equal to, and we saw that in the last module, that's that combination. So that's n choose x. So remember that n would be the number of trials and x would be the number of successes times p raised to the power of x. So remember that p is the probability of success.
Times, right?
Yeah, that's times. So I'll put this in a set of parentheses. Times q raised to the n minus x. And I don't know what happened to, okay, here it is. All right, so just like in the last chapter when we had the formulas for combinations and permutations, we're not going to use this formula per se. We're going to use the function in the calculator. But there are a couple of problems where they want you to kind of write out what n is and what p is, right? But we won't calculate this formula per se. We'll just use the function in the calculator. All right, so this is one way you may see the binomial distribution formula, or you may see it this way. P of x is equal to, and now this is just another way to write a combination, right? Instead of writing it out in this notation, n choose x, you can also write it out in this notation, right? So that is still a combination, n choose x. And then everything else remains the same. So that's times p of x times q raised to the n minus x. Okay. Now we're actually going to use the binomial distribution formula in the calculator. So let me just bring up the calculator. All right. Okay, so we're going to use something we hadn't used before. On the third line in my calculator and above this vars, which is short for variables, you see distribution, D-I-S-T-R. So if I click second, and let me just reset my calculator real quick. All right, so if I hit second and vars, which is distribution, here are the distributions we're going to be dealing with. We're going to deal with the normal CDF, and if we scroll down, we're going to deal with the binomial PDF and the binomial CDF. Okay, so I'm going to explain the difference between the two.
Normal CDF.
Yeah, normal, because that's in the next section. But in this section, we're going to use the binomial PDF and the binomial CDF. All right, so we're not going to use these formulas per se. These formulas are this binomial PDF form in the calculator. Okay. So now here's the difference between the two. To find the probability of exact successes. Okay, we're going to see a problem that actually deals with this. You want to use the binomial PDF. Right, so if you were trying to find the probability of, let's say, exactly 4 successes, whenever you see that word exactly, you're going to use this binomial PDF. Okay. Now this binomial PDF is going to take 3 parameters. You must first have to put in N. So remember that N is the number of trials. You have to put in P, which is the probability of success. And then you have to put in X, which is the number of successes. All right, and that's to find the probability of exact successes. You're going to use a binomial CDF to find the probability of successes at X and below. So remember that X is the number of successes. So if you want like the probability of less than 4 successes, right, you want to use the binomial PDF. I mean the binomial CDF, excuse me. So the binomial CDF, it finds the probability of that number and all below. Okay, so you still put in the same 3 parameters, N, P, and X. Okay, so to put some meaning to these, the binomial PDF stands for the binomial probability distribution function. The binomial CDF stands for the binomial cumulative distribution function. So if you think about the word cumulative, like the final exam is going to be cumulative. It's going to cover everything prior in the course. So when you think about the binomial CDF, it's going to give you the probabilities of everything before the probability that you're actually given. All right, so it's going to give you the probability of that value and below. Okay, so that's the difference in the two. Okay, there are also a couple of more formulas. Now the calculator is not going to help us calculate these formulas, but we have the mean, right, which you may see it written sometimes as, this is actually called mu, right? That's one of the Greek letters of the alphabet. So mu and mean are exactly the same. The formula for mean or for mu is n times p. Right, so it's not too hard to calculate. You just take n, which is the number of trials, times p, which is the probability of success, and just multiply them. The standard deviation that can also be written as sigma. So this circle with the funny looking squiggle toward the top, that is sigma. Okay, that's also one of the Greek letters of the alphabet. The formula to find the standard deviation is equal to the square root of n times p times q, where n is the number of trials, p is the probability of success, and q is the probability of failure. And then lastly, to find the variance, and the variance is written as sigma squared Okay, since these are formulas, I'm going to just put them in boxes. The variance is equal to sigma squared, and to find the variance, you just simply multiply n times p times q. So the mean, the standard deviation, and the variance, you're going to have to calculate those by hand. So any questions about the formulas? Okay, now we're going to look at some problems on the handout, and then we'll actually get to the problem that's on the lecture note or in the lecture slides. All right, so if you look at the Module 3, Part 1 handout, all right, we're going to take a look at number 1. All right, and it says, assume that a procedure yields a binomial distribution. Right, so they're telling us that this is a binomial distribution. So all of those conditions apply, right? It has a fixed number of trials. Each trial is independent. Each trial has the same probability, and there's a fixed number of trials. Right? So it says, assume that it's a binomial distribution with n equal to 49 trials, and the probability of success for one trial is p, which is equal to 0.34. Find the mean for the binomial distribution, round it to at least one decimal, and then we're asked to find the standard deviation. Okay. So if you look back at the formulas, the mean is simply going to be n times p, right? And they give us n, right? They say there's 49 trials. They give us p, which is 0.34. So I'm just going to multiply the two together. So 49 times 0.34. 49 times 0.34 is 16.66, but if we round to one decimal place, 16.7, right? So that's the mean. We're also asked to find the standard deviation. So for the standard deviation, that formula is the square root of n times p times q. So we know that the n is going to be 49, right? So all of this is still within the square root. So we have 49 times P, which is 0.34 times Q, which is, we got to calculate Q, right? So remember from our formulas, Q is equal to 1 minus P, right? And P is 0.34. So Q is equal to 1 minus 0.34. And 1 minus 0.34 is 0.66, right? So as I kind of alluded to, normally you're going to have to find Q, right? So we're going to multiply 49 times 0.34 times 0.66, which is Q, right, and take the square root. So I'm going to put that into the calculator. So this is the square root. So notice it gives me a begin parenthesis for my square root of 49 times 0.34 times 0.66. I'm going to close off my square root. And if we round to 2 decimal places, we get 3.32 as the standard deviation. Okay, so in order to find the mean and to find the standard deviation, right, you simply follow the formulas, right? All right, now we're going to take a look at problem number 3. And this is still on that first handout. And let me make sure that's the right problem. Problem number 3 is right here. All right, so it's problem number 3 on part 1. All right, so it says a baseball player has a batting average of 0.39. What is the probability that he has exactly 6 hits in his next 9 at-bats? Right. So it says in the box below, type in what you entered into the calculator. All right, so we're going to work all of that out here. Okay. So now they give us like 3 numbers. It says a baseball player has a batting average of 0.39. So is that 0.39, is that N, is that P, or is that X? So just remember that N is the number of trials. P is the probability of success, and X is the number of successes. Okay. So now we know it's a binomial because either he's going to hit the ball or not hit the ball, right? So those are the 2 outcomes, either hit or miss. The proportion or the amount of times that he's successful at that is what? 0.39. So is that N, P, or X? Well, notice the probability is always going to be given to you in one of 3 ways, either as a fraction, as a decimal, or as a percent. So the 0.39, that's his probability of success, right? So he has like a 39% chance of hitting the ball. All right, so the probability is going to be given 1 of 3 ways, either as a fraction, a decimal, or a percent. So here they give it to us as a decimal. So as we keep reading, it says, what is the probability that he has exactly 6 hits in his next 9 at-bats? Right? So what is 6 and what is 9? Right. So now here's just a hint. The number of trials should always be bigger than the number of successes. Right? So 9 is his number of trials. Right? So at his 9 times, well, first off, he has a 39% batting average, whether he's going to hit it or not. That's probability of success. We're going to find that probability with his next 9 at-bats. So 9 is going to be the number of trials. 6 is going to be what? The number of successes. So we want to see if he can get 6 hits, or what's the probability of him getting 6 hits in his next 9 at-bats if his batting average is 0.39.
And the trials should be a bigger number than the
X, than the number of successes. Okay. So since we're finding an exact probability, we're going to use the binomial PDF, right? Because remember, cumulative is from that number down. PDF is for exact probability. So now we're just going to put in the 3 parameters. The first parameter we have to put in is n. So that's 9. The next parameter we have to put in is p, which is the probability of success, which is 0.39. And next we put in the number of successes, which is 6, right? So this is what we're going to put into the calculator. So we pulled out n, we pulled out p, we pulled out x. Since we're finding the exact number of 6, right, we're going to use a PDF. So I'm going to recall the binomial PDF. So I'm going to hit second in variables, right, which brings up the distribution. I'm going to scroll down to the binomial PDF function. I'm going to put in 9, comma. Okay, you must separate all of these parameters with a comma. 0.39, comma 6. And we see that he has a batting average of 0.67.
So that's when you hit that binomial function, that's how it comes up?
Well, yeah, I'll do it again. So when I hit second and distribution, and when I go down to binomial PDF, you have an 84. Is it showing the same way on your calculator?
No, it's separating the number. It has the trial, the probability, and X value.
I got you.
That's why I was wondering.
So,
I
yeah.
put my numbers separate.
So that would be trials. This would be the probability. And then this would be the number of successes. All right, so I put in 9 comma 0.39 comma 6, and we get 0.67. So is it highly likely that he's going to get 6 hits in his next 9 at-bats?
No.
No, right? That's 0.067. So like if I were to move that decimal 2 places to the right, it's like he has a 6.7% chance, which is highly unlikely. Probably could, you know, on his best day or whatever, but it's highly unlikely. All right, any questions about number 3? So now we're going to backtrack and we're going to go to problem number 2. Okay, because problem number 2 is a multi-part question, right? And it has a little bit of everything in it. Okay, so here we've seen how to calculate the mean, the standard deviation, and we use the binomial PDF to find an exact probability. So now I'm going to go back to problem number 2. All right, so here again, this is from the first handout. So the question reads, a local county has an unemployment rate of 6.6%. So notice they're giving us a percent, which is an indication that that's the probability of unemployment. A random sample of 18 employable people are picked at random from the county and asked if they were employed. A says find a probability that fewer than 4 people in the sample are unemployed. B says find the probability that more than 2 people in the sample are unemployed. C says find a probability that at least 2 people in the sample are unemployed. All right, so this is a 3-part A, B, and C. You got a question?
Oh, no.
Okay.
I'm sorry.
Okay. So now what I've done at the very bottom, remember what constitutes a probability distribution, right? You must take all of the probabilities, and here, since we're randomly sampling 18 people, so what I have down here is a probability that 0 people are unemployed plus the probability that 1 person plus the probability 2 person or 2 people, all the way up to 18 people, right? If you add all of those probabilities up together, it must equal to a 1, right? I'm just noticing that my screen is a little bit bigger than. All right, so that's what you see at the bottom. The probability of 0 plus the probability of 1 plus all the way up to the probability of 18 people, right? Because there's 18 people in the sample. Add up all those probabilities, those probabilities should equal to 1. Okay, because we're going to kind of use this to help us figure out what we need to put into the calculator. So I'm going to go back to the top. It says a local county has an unemployment rate of 6.6%. So this 6.6%, is that in P or X? That should be P, right? So P is equal to 6.6%. If we change that to a decimal, right, we would drop the percent symbol and move that decimal 2 places to the left. So P is going to be 0.066. That's the probability of success. Or in this case, the probability of unemployment. right? Because there's two outcomes. You're either employed or not employed. A random sample of 18 employable people are picked. So what is the 18? Is that N or is that X?
Number 18.
So is that the number of trials?
Mhm.
Or that would be the number of trials, right? So N is equal to 18. All right. All right, so we've established P and N. X is going to be given in the actual problems. So A says, find the probability that fewer than 4 people in the sample are unemployed. So now I want to find, okay, so what I have down here is I have all 18 trials, right? Probabilities for 0 people being unemployed, all the way up to the probability of 18 people selected being unemployed. All of those probabilities equal to 1. So it says find a probability that fewer than 4. So now, what probabilities do I actually want to start from? Do I want to start from 4 and go down? Or do I want to start from 3 and go down? 3, right? Because it says fewer than 4, not fewer than or equal 4, right? So I want this, all 4 of these probabilities. Now I can do them one at a time. I mean, I can find the probability of 0 in the calculator, right? Using the binomial PDF, I can find the probability of exactly 1, exactly 2, exactly 3, and then I could add all 4 of those things up. Or I could use the binomial CDF, and since it's cumulative, it's going to give me the probabilities of all of those things from 3 to 0 added together. All right, so for A, I'm going to use the binomial CDF. Remember, we have to put in the parameters N, so N is 18, times or comma P, which is 0.066. And then for the number of successes, we're going to put in 3. So this is going to give us a probability for 3, 2, 1, and 0 added together. So let's put that in. Okay, so I'm going to recall the binomial CDF function. And it's 18, comma, 0.066, comma, 3, and 0.972. So that's a good chance if you pick 3 people that those 3 people won't be unemployed, right? That's like a 97% chance, which is really close to 100. Okay. All right, so now you may want to draw this out and you may not want to draw this out, but I'm kind of illustrating the numbers that we put into the calculator. All right. So let me erase my little line. So let's look at B. B says find a probability that more than 2 people in the sample are unemployed. So if I want more than 2, I don't want more than or equal to 2, right? So I want these probabilities from 3 to 18. But I'm running into a slight problem because the CDF function on the calculator is going to only calculate below. All right, so here's what I'm going to do. Since all of these probabilities together from 0 to 18 must equal to 1, right? I can find out these probabilities, subtract it from 1, and that would give me 3 through 18. So now this is how I'm going to put this in a calculator. It's going to be 1 minus the binomial CDF for 18, 0.066, 2. All right, so the calculator is going to give me these probabilities added up together, right? So that's the 18, 0.066, 2. And once we subtract it from 1, it's going to give us the complement, or the P through 18. All right, so anytime you see more than or greater than, you're going to use that 1 minus that binomial CDF. So I'm going to put this in as 1 minus the binomial CDF of 18, 0.066, 2, and we get 0.112. All right, so there's about 11% chance that there's 0.112. All right, there's 11.2% chance that more than 2 people we sample in that group of 18.
So if on your calculator you put 1 minus the binomial CDF,
right?
Otherwise,
do it in yours.
Yeah.
You want to go to the home screen, and then put 1 minus,
okay.
And now call up the binomial CDF function.
Gotcha.
Okay. All right. So just calculate it to make sure you get that 0.112.
What was it?
0.112. You got it? Okay.
0.11.
I rounded, to the nearest 3 places after the decimal.
Got it.
Okay.
That's what I got.
All right. So that was that was B. So C says find the probability that at least 2 people in the sample are unemployed. So now if you want at least 2, that means you could have 2, 3, 4, all the way up to 18, right? So at least 2, I must include 2. So I'm going to just draw that out. So we want the probabilities for 2 through 18 people, but the calculator only gives us the cumulative from that number below. So we're going to use 1 minus the binomial CDF, and we're going to put it 18. We're going to put in the probability of unemployment, and we're going to put in X as 1, right? Because the CDF for 1 is going to give us the probabilities for 1 and for 0 added together. So we can subtract from 1 to find the probabilities for 2 through 18.
Okay, say that again.
Okay, so the second part of this, where it says the binomial CDF for 18, 0.06, 1, that's going to give us these probabilities added together. So if we subtract from 1, right? Because all of these things together must equal to 1. It's going to give us what we're asked to find, right? Because remember that 1 is actually 100%, right? So anytime you see more than or at least or greater than, you want to use the 1 minus. All right, so if we put this in the calculator, 1 minus binomial CDF 18 comma 0.066 comma 1 Okay, so I'm just rounding everything in 3 decimal places. So that's 0.335. All right, so any questions about the handout?
The only question I have, Mr. Cummings, is when you're doing these answers, because I noticed I kind of made some of those mistakes on my test, is the rounding. Like when it says to, like this one we just did.
Okay.
Unless it tells us to.
Now the thing
about each answer
yeah.
these 3 decimal places, so we would not round that 335 to, well, no, because the 2 is.
That's right. We would keep it, yeah.
Okay. So that's what.
I got you. And then on some of the problems, they want 2 decimal places, and some they want 3 decimal places.
So if the number, if it says round up to at least 2 decimal places, that means at 2 decimal places, the first number past that, if it's not 5 or more, then I don't round.
Right, it stays the same. Okay.
So that's why I get mixed up with my round. Either I'm just not paying attention. Okay, got it.
All right. I dropped my pen. Okay, and let's take a look at the lecture notes. Now, as far as while we're on the handout, as far as this handout is concerned, you will notice that on the last page of the handout, there is the answer key. It kind of gives you the same functions, and normally there's some questions, but why are we using 2 and 3 and 1 minus? So I kind of drew it out, right, using the fact that all of the probabilities must equal to 1. All right, to kind of show why we're putting what we're putting into the calculator. All right, so let's take a look at the lecture notes. All right, so this is actually what's on the slides. It says the Pew. Now there is no answer key for the lecture note thing, so we're going to go through these. It says the Pew Research Center reported that approximately 30% of internet users in the U.S. use Pinterest. Suppose a random sample of 15 internet users is taken. Use the binomial probability distribution to find the following probabilities. Okay, so here again, in the question, they give us the probability of success, right? Either a person is going to use Pinterest or they're not going to use Pinterest. And it also gives us the number of trials, right? So N or P is going to equal to 30%, which is 0.3. And N is going to equal to 15, right? Okay, so I'm going to make that look like a 15. So let's look at A. A says find the probability that exactly 4 of the sample people use Pinterest. All right, so we're finding an exact probability. So we're going to use the PDF, right? So we're going to use a binomial PDF for 15, 0.3, 4. So if we put that into the calculator, just going to clear it out. So that's the binomial PDF. N is 15. P is 0.3. And X is 4. And it doesn't tell us where to round, so we're going to round to 3 decimal places. So that's 0.219. Did you get the? Did you use the PDF? Okay. No, X value is going to be 4. Right? Because 4 would be the number of successes. Now the probability is going to be 0.3. Right. Okay. Okay, so 0.28219. That's right. That's right. So it's like a 21.9% chance that 4 people out of the 15 use Pinterest. So if I did, let's see, 21.9%. All right. Okay. So B says find the probability that fewer than 3 people use Pinterest. So like if I were to map that out, P of 0 plus probability of 1 plus the probability of 2 plus the probability of 3. All right. So if I map it out like we did earlier, like the probability of 0 through 15, we want the probability that fewer than 3, right? So fewer than 3, we're going to use, well now for this one we won't use 1 minus because we're using fewer, and the CDF function it gives us from that value less. That's only if we got more than 3. Okay. So in the calculator we want to use binomial CDF. Okay, 15, 0.3, 2. I'm not using 3 less than that, so that would be 2. Right, that would be 2. You said we're doing how many places? 3 decimal places. Okay, so 127. That's right, 0.127. Which would be And then for C says find the probability that more than one person uses Pinterest. So more than one, I'm actually going to find the probabilities for 2 through 15.
One person. Yeah.
But I'm going to have to use that 1 minus, right?
Right.
So it's 1 minus. That's right.
Wait, I got
965. That's right. That's right. 0.965. Now D is a little bit tricky. Well, I shouldn't say it's tricky, but there's a couple ways you can use D. D says find a probability that the number of people who use Pinterest is in between 1 and 4 inclusive. So what that means is it's in between 1 and 4, and you have to include 1 and include 4.
that's 4.
That's right. So that means inclusive means you have to include 1 and include 4. All right. So now this is how we're going to put this into the calculator. You could find use the binomial PDF. You could find 1, 2, 3, and 4 and add them all up together. That might take a minute, but you can do that. Or you can use a CDF function. So I'm going to put it in this way. I can find a binomial CDF from 4, but that's going to give me 4 all the way down to 0, right? So the binomial CDF from 15, 0.3, 4 minus, and then I'm going to subtract out what I don't want. So that's minus the binomial CDF 15, 0.3, 0. And that's going to subtract out, really it's just going to subtract out 0. You could use a PDF. I'm putting it in this way because let's just say they wanted you to find 4 through 14. You would use the PDF, you would use the CDF because there would be more probabilities. So this is going to work in all cases. So we're going to take the probability from 4 down to 0. That's the first part of the function. And then we're using that second function to subtract out the probabilities below 1, which in this case is just 0. So this is going to equal to CDF 15, 0.3, Oh, I'm sorry. Okay, 4. So that's going to give me from 4 down to 0. But I'm going to subtract out the binomial CDF 15, 0.3, 0. And that's going to give me 0.51. So that's 0.511. My calculator is still showing. All right, so that one's a little bit involved. Okay, you have to use a couple of functions, or you could just, find each probability separately using the PDF and add them up together. You should get that same result. All right, so E, the next one says find the mean. So just remember that the mean is N times P. So N is 15, 0.3. So if you multiply those together, I believe you get 4.5. Yeah, 15 times 0.3. And then the standard deviation is the square root of N times P times Q. All right, so that's 15 times 0.3 times Q, which is 0.7, right? Because if you subtract 1 minus 0.3, right, that's where that 0.7 comes in. So I actually write that in. So 1 minus 0.3, that's Q. So then if I simplify that, this is the square root of 15 times 0.3 times 0.7. And if we calculate it, the square root of 15 times 0.3 times 0.7, we get 1.775.